Hello again, grade 7s. In today's lesson, we are going to talk about what effect outliers have on a set of data, specifically on the median and the mode. And then we'll discuss whether or not the outliers should be removed from the data set, depending on how heavy of an influence they do have on that set of data. The learning outcome for this lesson is to determine the effect on the mean, median, and mode when an outlier is included in a data set. If we have a data set and we identify we do have some outlying data points, we should remove the outlier if it has a major influence on the median and the mean. I didn't include mode there because the removal of the outlier should have no effect on the mode. The mode is the most frequently occurring number. Presumably, an outlier is just a single number on its own. Therefore, it should not have any effect on the mode. So we only need to worry about the actual median and the mean. If you look at different data sets, if you have like smaller data sets, for example, I only had a data set of 4 data points, and one of those data points is an outlier, the outlier would have a major effect on the data. If you had a much larger data set where you had like 100 data points and only one of those is an outlier, I'd expect the outlier to not have much of an effect on the rest of the data whatsoever. Okay, so let's do an example to show when we should or should not remove an outlier from a data set. So I have a person completes a bunch of 100-meter sprints, and we can see all the times it took for them to complete the sprint. And I want to A, determine the range, median, and mean for the above set of data. And then 2, identify any possible outliers. And then 3, we want to justify, which means we need to explain or kind of prove whether or not the outlier should be removed or not. Okay, since we're going to do a calculation for range and median, it would be very helpful to take the data and to organize it. So I want to organize it from smallest to biggest. So the smallest number in this data set is 16.5. Then 17.1. Then 18.5. Then 19.0. Then 20.2. Then we have 20.5. Then we have 21.4. And then 24.5. And then finally 40.4. Okay, let's calculate the range first. So your range, it is a positive difference between your largest and smallest value, or your maximum value and your minimum value, and a difference means subtraction. So this would be your maximum value is 40.4. Subtract 16.5. And then I get my range would be equal to, I get a number of 23.9 seconds. Let's figure out the median. So the median is the middle number. So let's see what happens if we start to go in by one number every time. Okay, so if we go in by 1, go in by 2, go in by 3, go in by 4, and then this remaining number would then be the median. So my median in this situation, which is the middle number in the data set, your median, I'm just going to choose red color, your median would be 20.2 seconds. The mean, well, this is the one where we actually have to do a little bit of work to calculate it. So we need to figure out the sum of all the data points. And for the mean, you don't need to put the data in ascending order to do this. Although you can just, it doesn't matter whether it's in ascending order or not, you're going to get the same sum. Okay, so let's figure out the sum. So the sum would be equal to, let's do 16.5 plus 17.1 plus 18.5 plus 19.0 plus 20.2 plus 20.5 plus 21.4 plus 24.5 plus 40.4. And we calculate this sum, it should be a total of 198.1. If we add units here, it'd be seconds. Okay, to calculate the mean is equal to the sum divided by n. N is the number of values in the data set. So in this case, n would be equal to, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So we take the sum, which is 198.1 seconds, divide by 9, and then I believe I get a repeating decimal number. So I'm going to get 22.0111, and then I just keep repeating this. Now, once again, if we get a decimal number, let's try to round it to the nearest tenth of a decimal. So the nearest tenth of a decimal would be this digit. And to round, we need to look at the following digit. The following digit's a 1. And if that following digit falls between 0 and 4, it means we do not round up. Therefore, my mean would be 22.0, and we'll add the units there, seconds. Okay, it says identify any possible outliers. So your outliers are going to be either at the start of the data or at the end of the data. So start of the data, 16.5. Is that drastically different than 17.1? No. Okay, so 16.5 is not an outlier. How about 40.4? Is that drastically different than 24.5? Yeah, for sure. I mean, if I were to make a guess as to what happened when this person was running, maybe on that 40.4 second run, they might have tripped and fell, or they might have sprained their ankle. And then by the time they got up and running again, their time was quite a bit larger. So our outlier is going to be just the one number, 40.4. Okay, C. We need to justify whether or not we should remove this outlier or not. This is a bigger data set. I have 9 points. So, I mean, the outlier, it depends how big the outlier is or how far off it is in terms of its influence. So what we're going to do is we're going to remove the outlier and then recalculate the mean and the median. And we want to see how much of an effect that outlier has on the mean or the median. So let's pretend that we're just going to get rid of the outlier. Okay, so this outlier is gone. Let's pretend like it's not in the data set anymore. And what I want to do is I want to recalculate the mean and the median. Okay, let's do the median first. So now I only have 8 points in the data set. So let's go in by 1, go in by 2, go in by 3. And this time around, I have 2 middle numbers. I have 19.0 and I have 20.2. If you have 2 middle numbers, and let's change the color again. If you have 2 middle numbers, the median is going to be the midpoint of these 2 numbers. Now, this one's probably not as easy to see. To figure out a midpoint, you just take the 2 numbers, add them up, and divide by 2. So really, it's just like figuring out the average of 2 numbers. So our median, the new median, would be equal to 19.0 plus 20.2. And we want to divide this by 2 to get the midpoint. And that would be 39.2 seconds. Divide by 2. And then I get a median that is 19.6 seconds. Now, to calculate the mean, we could just add up these 8 numbers, all the numbers without the actual outlier. But it turns out there's a much more clever and efficient way to do this. We can actually make use of our previously calculated sum. So that's this one, 198.1. And we can use that to figure out what the new sum is. And here's how we would do it. The new sum would be equal to the old sum. Subtract. Well, what's the difference between the new sum and the old sum? Well, the new sum doesn't have the outlier. So the new sum would just be the old sum subtract the outlier we have removed. Okay, so that would be the old sum is 198.1. Subtract the outlier 40.4. And then this new sum would be equal to 157.7 seconds. And also, because we've removed one data point, our n value isn't 9 anymore. If we take the outlier out, we'd now have 8 data points. Okay, so let's calculate this new mean. So we'd have mean is equal to sum divided by n. This is going to be the new sum divided by the new n value. So that would be 157.7 seconds. Divide by 8. And then this is going to give you 19.7125 seconds. It is a terminating decimal. And again, we'll do some rounding here. So we want to round to the nearest tenth, which means I have to look at the following digit. The following digit's a 1, therefore I do not round that 7 up. I just keep it as 7. So the mean would then be equal to 19.7 seconds. Now, should we remove the outlier or not? Well, let's compare what happened to the mean and median after the removal of the outlier. Okay, with the outlier included, the median was 20.2. When I removed the outlier, the median became 19.6. So it went down a little bit. It went down by 0.6. That's not a huge drop off though, so I wouldn't be overly concerned with that one. But let's look at what happens to the mean. So the mean was initially 22.0 seconds, and it dropped all the way to 19.7 seconds. In the context of a 100-meter race, so that's a difference of a little more than 2 seconds. It is quite a bit of a difference. So because the mean was quite a bit affected, I would say, yes, you want to remove that outlier, especially if the person actually did trip when they were running. Like, you would never include that data point because that wasn't a proper run. Okay, so let's just summarize this in a complete sentence. So I'm going to say, although the median was not significantly affected by the outlier, the mean was and since the mean was, we should remove the outlier. The mean was Therefore, remove the outlier. Okay, so that's our test to figure out whether we should remove an outlier or not. See what the median and the mean is beforehand, then recalculate it after you get rid of the outlier or outliers. And then if there's a significant change, you get rid of it. If there isn't for both the mean and the median, then it's okay to keep it. All right, just a few questions to practice. So in the MathLink 7 textbook, we've got pages 444, 445, and just 3 questions, numbers 4 through 6. And then the next lesson, we'll finish up the unit of study on working with data. And I will talk to you then.